today. Hey, I see some people I know in here. Okay. My name is Spencer Ortega.
I'm Austin Tao.
And I'm Adrian Trujillo.
And we worked on anomaly detection for dynamic graphs, which was sponsored by Intuit.
All right, so what is an anomaly? An anomaly is something that deviates from what is standard, normal, or expected. An anomaly in data in particular can point to unusual patterns, and these unusual patterns can give us a significant insight on a variety of problems.
So the problem that Intuit is trying to solve using anomaly detection is finding tax fraud within the millions of tax returns they process each year. But our mentor Kumar suggested we look at other applications of anomaly detection, such as spam filtering, finding unwanted network activity, and finding a tumor in an IMR scan.
So our solution / deliverable to this problem will come in the form of a Python module. So this Python module should be able to do 3 things. And first, it should be able to ingest user graph data. Second, it should be able to detect anomalies using the CAD algorithm, CAD standing for Commute Time-Based Anomaly Detection for Dynamic Graphs, which was given to us by our mentor Kumar. And last but not least, visualize these anomalies using a network graph model. So to verify that our module actually worked, we had to test it out on a real-world data set. So we focused on the DBLP, which is a database that consists of millions of collaborations between researchers all over the world. And so in the context of the DBLP, an anomaly would be either a sudden increase or decrease in collaborations between 2 researchers, or a researcher doing research in a different specialization than he or she was doing before. So here we have a visualization of the top 100 collaborators in 2012. So when we run our anomaly detection on this data set, we find a bunch of cool anomalies here in red. And so one we focused on was between Fatos Safa and Leonardo Baroli. And so after further investigation, we found out in 2012 they were doing research in mobile networking, and in 2013 they switched their specialization to e-health, so which is the cause of the anomaly.
So we learned different applications of anomaly detection, such as detecting fraud and finding anomalies in a network collaboration. We also learned to study graduate level research, such as the CAD documentation. And we learned to research open source data sets, such as the DBLP dataset and the NROD dataset. And lastly, we learned to visualize graphs in Python using a network graph model.
So our next step, if we had more time, would be to implement spectral clustering, which essentially condenses down a graph and makes it easier to visualize for the user. The other thing that we wanted to do was to explore more distance metric algorithms. Since our mentor Kumar's paper was released in 2011, there might have been better suited algorithms released since then. The last thing that we wanted to finish up our work with was to test our code on more open source data sets to just further test the validity using real world open source sets of data. And so, at this time, I'd like to give some acknowledgments to both of our professors, Dr. Kumar Sricharan and Dr. Glenn Bruns, for helping us and guiding us through this project. Thank you.